Welcome everyone to part 5 of the ESTeem wireless training class. In the first 4 sections that we have covered, we've covered everything from the basics of radio communication, antennas, cables, how to design a radio system from a math model analysis, conducting a radio site survey, commissioning the network, and also took a look at how our radios fit within this greater world of radio communication. What we're going to do today, and actually it will roll into part 6 of this training class also, is take a look at the specifics of actually how to program the radio for this wireless Ethernet communication. It's a little bit unique in the fact that Ethernet was really never designed for wireless, and there are some items that we need to cover and make sure that we make allowances for when putting a wireless network over Ethernet. And we're going to take a look exactly what is involved in that as we go through this class. So as an overview for the next few days, what we'll have here is we're going to just briefly cover what wireless Ethernet is. Where does it fall within the overall Ethernet world? What are the things that the wireless Ethernet system actually replaces? Then we're going to take a look at the beginning of programming the radios. What's necessary? Setting the IP address. We're going to give a brief introduction on one of the first utilities we're going to cover, which is the Discovery utility. We do actually have in the future some classes that will go into much more great detail on what these utilities are and how to program with these. But for our purposes now, we'll give an introduction into what these utilities are and how the primary uses of those are going to be. We'll next take a look at the modes of operation within the radio. As you'll see here, there's 7 to 8 modes of operation within each one of the radio modems, and we will take a look at which ones are going to fit best for most applications and how those are actually used in different types. The final thing that we'll take a look at in this section in part 5 is how to actually get the radios to both either act as a repeater or work into what's called meshing. When we talk about what the radio capabilities are, you see the term come up, and a lot of different wireless solutions are using this term meshing. We're going to show exactly how that operates and how to get this mesh network to function the way that we want it to work. Once we've completed that, we'll then probably finish up for this section. Part 6, which will start, has the other modes of operation of the radios, the router modes, masquerade modes, and ultimately the mobile station modes. Within that section, we're also going to get into much greater detail on what the security mechanisms are. Those a lot fall under the mobile environment, so it'll make much more sense to cover it during that period of time. So let's go ahead and start with something from its basic nature. When we're talking about Ethernet, what we're talking about is Ethernet is actually a stack, or what they call basically multiple types of communication put together to give us the information that we want to see. When we're making links on how this works, the physical would be the electrical interface, the actual RJ45 connector that goes into the radio. The link would be how, at a device level, the radio communication works. We get into the network and transport layer. This is your TCP/IP. This is your network protocols fall within these layers. And ultimately, the session, presentation, and application are the programs that run on top of this. So the way that this actually works, and the reason that we define this, is the wireless Ethernet. What we're really doing is we're replacing these 2 lowest layers in this Ethernet stack, the physical and the link layer. As you notice, the protocol layers between the network and transport layer, those don't even actually apply to the radio and how we transfer information across there. The radio itself and every device that we have has a TCP/IP address, but that IP address is for programming of the radio or future troubleshooting of the radio. We don't actually look at the protocol that the radio is transporting at all. It does not matter whether it's TCP/IP, NetBEUI, IPX. The protocol is completely transparent to the radios themselves. So how do we start this? What are some of the things that we need to make sure that we have taken care of? The first thing we'll take a look at is what are the basic radio layout? What does it look like to get this programming started? What type of hardware are we going to need? What are the antenna connections going to look like? Once we've established that, we need to make sure that the radio has the same IP subnet that the computer that it's connected to. There is a utility that's available. All of these utilities are available for download from our webpage. The first one we're going to use is what's called this discovery utility. And what this discovery utility allows you to do, it is designed so that you can match up the connected radio's IP address so that it matches up to the computer you're talking to. There are many different ways that you can actually program the radio. The two primary ways that you can program the radio is through the web interface, or you can use what's called the ESTeem Network Suite, which is a programming software that we have done to greatly simplify how the radios are actually programmed. It's a very visual. You put the radios onto a single screen, and you draw the lines in between it. Well, instead of starting with that, though, I think the best thing to do is get a good working understanding of what's happening in the background. And another nice feature is that if you understand how to program it using the web interface in the radio, that you'll always have access to the radio. It does not have any special software any software browser will use. So you could go to any computer, any terminal that has a web browser on it and be able to program those radios without any special software. So what does the basic hardware look like? Well, the first thing we always have to do is any time before you apply any power to a radio, you always want to make sure you have an antenna installed. Depending upon the radio itself, it's either going to have a single antenna connection or a dual antenna connection, but this has to be done before any other step is taken onto it. Before any power is applied, you'll always want to make sure that there is an antenna installed. Because as soon as the radio starts booting, it will start transmitting information. And the problem is if you don't have an antenna on there, everything that we're transmitting out immediately comes back into the radio and can cause damage as far as the output goes. So it's a good rule of thumb that anytime that you start working with a radio, whether it's our radio or any other manufacturer, you always start with an antenna. Once that's done, we're actually going to program our radio through this PoE supply. In a couple previous ones, we have talked about how all these devices come in. This PoE injector is very simple. What it actually does is it has both an in and an out. And what it will do is it will take the data that's coming out of the computer, and it will then add to that on the outgoing side. We're going to add to that the DC voltage that the radio needs to get both data and power. That's where the PoE side of it comes in. So as a basic starting out or a basic network layout, you're going to have the antennas connected to the radio. The radio then is going to be plugged to the output side of your PoE injector, and the input side is going to be plugged into the PC. As I mentioned to you earlier, there are multiple modes of operation. Now, these radio series that this is going to cover, everything within our higher throughput Ethernet radios, so this is going to cover our Horizon series. So this is going to cover the Horizon 900, Horizon 2.4, Horizon 4.9, or Horizon 5.8. The 195 narrowband radios and the 210 and the Edge 900 each has a separate mode that they can go into, different modes of operation, and we're going to cover those in future training sessions. So this modes of operation and everything that we're going to see here applies to the Horizon series to start with. The modes of operation, really what they come down to is each one of them will have a use depending upon the application of the environment that it goes into. What I mean by that is you notice the first three that we have here start with this thing called an AP. Well, what the AP stands for is access point. These radios are actually performing two functions at the same time. It's actually functioning as both an access point and either a bridge, router, or masquerade. These terms, best think of it is, let me go ahead and back up one slide. It's easiest to look at it when you're thinking of the radio itself. If what these terminologies are referring to is what is the relationship between the Ethernet side on one side and the wireless side on the other. Wireless over here. So if we're talking about a bridge, then the bridge interface actually bridges those two together. A router actually creates a router between the Ethernet interface and the wireless interface. A masquerade creates essentially a firewall between those two. So what this is telling us then is these first three modes, these are going to be used for our fixed locations. These are going to be the radios within the network that are not going to be in a mobile environment. Mobile environment is going to be could be anything from maintenance vehicles to overhead cranes to automatically guided vehicles. There are many different things where you're changing between base stations. Those are going to be the modes that fall down below. And as you see here, we have 4 different station modes: station bridge, ether station, station router, and station masquerade. All of these fall within the category of mobile. Okay, these are going to be the devices that are going to roam between our fixed points, which are our access point, bridge, router, and masquerade. Now, the Ethernet only mode is the only one that's a little bit different. That is actually for maintenance. It's the only time that it would be entered there are very special conditions. But what that'll do is that'll turn on the Ethernet side of the radio, and the wireless side will be completely turned off. So the first thing we're going to concentrate really is the most commonly used mode of operation, which is the access point bridge. Now the access point bridge, the reason it's used predominantly is really this is what most people want the radio modems to solve. Whatever comes in one side will actually be put out through the radio and spit out the Ethernet port at the opposite side. Or even if it's a multi-point environment, what one comes in one direction will go out to the remote that has that Ethernet device that's where the communication is assigned to. So all the data from both the wired and the wireless side are shared. Why this is important and why everything doesn't use this mode of operation is we need to also consider, because this is usually used for a fixed location or for a small or isolated Ethernet network, if you were to put this mode of operation attached to, say, the plant internal wireless or plant's internal Ethernet network, all the communication or all the devices are going to try to go out over the wireless link. The wireless does not break down which communication needs to go to which remote. That's where the other two modes of fixed point operation come in, the access point router and the access point masquerade. Both of those actually break apart the wireless interface and the Ethernet interface and will allow communication only through that has, or it's designated for that specific remote address. So the bridge will allow all that data to go through, but those are the conditions that have to be met. It will generally be a smaller network or an isolated network. So in other words, you're not putting this onto a plant-based network. If you're plugging it into just a single, say, PLC at one side and PLC at the remote, this is a perfect interface for it. It makes it very simple because you only need one single IP address, which is shared between this, and there is no routing required between this system devices. So it's a very simple interface. It's a very clean interface, but in a lot of cases, that's really what most people need. So when we make reference to it, that kind of covers the bridge side. When we're talking about access point, what are we making reference to? Well, this terminology actually came out of Wi-Fi. It is really the ability for a device to provide a wireless access for mobile clients. All of our ESTeem clients and those radios that support Wi-Fi clients can also work as access points. So for example, the Horizon 2.4 gigahertz and the Horizon 5.8 gigahertz can actually be access points for Wi-Fi clients also. But they don't necessarily need to be those. We primarily developed these so that we could make our own clients. So therefore, on the frequencies that don't fall within the Wi-Fi spectrum, say the 900 or the 4.9, we still can operate a radio as an access point and the devices that are connected to it. The only difference would be is that in those cases, those mobile clients are radios programmed as a mobile client. The idea behind this is that As an access point, the access point connects the mobile clients together in a fixed Ethernet network. It actually acts as the bridge between the wired Ethernet network and the wireless world. It was originally developed so that you could essentially expand the range between mobile clients. A mobile client to another mobile client is only going to get you the range that they actually communicate to each other. If we put an access point in between them, then they actually then double the range on who they're communicating to. So you'll have one client talking to an access point, and the access point will relay that and pass that to another mobile client. So therefore, increasing the overall range. Let's go ahead and take a look really at a picture of how this works. This will probably make a lot more sense once we see it here. The first thing we need to understand is there are three radios within this diagram that are going to be in the access point mode. That's going to be our fixed point here, our fixed point as a repeater, and then finally our remote site within this network. Each one of these radio will be configured as an access point for our purposes of this explanation, access point bridge. So whatever comes in on this Ethernet link is going to be passed across the wireless system and will arrive at not only this device, which currently is just a standalone repeater, but will also be relayed down here to this remote. If this is a small little isolated wireless network, that'll work just fine. If it's a much more complicated network, that's where those other modes of operation come into it. If there's any questions on which mode it needs to go into, please contact support. We'll be happy to walk those through you. But as you notice here, these radios are serving 2 points, 2 different purposes. They're not only acting as the bridge link between those, but they're also supporting these mobile devices. Okay? So we can support a mobile PLC, a mobile tablet. We could actually support a mobile device over here that actually has many different devices connected to it, either a masquerade router or what's called a station bridge mode. It can support a camera, a PLC, a computer that's actually attached within this device. So there's a tremendous amount of flexibility here. The key thing we need to understand is that when you see a mode of operation, that radio is actually performing both of those functions at the same time, functioning as an access point and a bridge. The reason that we need to define this is the fact that the bridge link between the radios is not defined by the Wi-Fi specifications or the IEEE 802.11 specifications. It does not define how the access points talk to each other. It says that they can, and the method that they allow to communicate to them is completely up to the manufacturer. Because of that, in its very nature, we actually had to develop this link between these radios ourselves. And because of that, it is a proprietary Ethernet link. So that is a certain level of extended security because you need only our radios communicate to each other on this bridge router or a masquerade mode. The next thing is that repeating in all modes of operation are supported into this Ethernet bridge. For example, you could actually have a station route, an AP router on one side and an AP bridge on the opposite, and those two will also still work when we're talking about creating these connections. We don't lose anything by actually going through a repeater. In other words, it takes away the open protocol equipment, but it's really designed to link our networks together. And again, these are the links that are fixed. In other words, these are the links that are going to be non-mobile. So a good example or what a diagram of what this would look like is if we had our main office here, a remote office out at a remote location, we could actually set these radios up in an AP bridge on all three of these, and we create a link between there that would follow this scenario. And this is kind of the baseline for also what our mesh network would look like. So let's start digging in a little bit on how we actually get this to work. The first thing we need to understand is there are multiple modes and there are different ways that we can program the radio. The first one, actually using the web interface, is a little more complicated in the fact that you're going to go through multiple pages, and each one of those pages is going to ask a specific question of the network. And that's really the purpose of what we want to instruct here today. We want to be able to go through those so that you can see what are the possible choices here and what do those choices actually stand for. Once we understand how to program the radio through this particular mode, what we can do is we can actually then use that same type of methodology to program the other modes of operation, or then we can use that as a comparison tool when we actually get in and start looking at the ESTeem network suite, which is the visual programming of the device. But understanding at this level will always be available to you. Any computer that has a web browser can program the radio at this level. So as we looked at earlier, the first thing that we need to do is we need to match up the IP address of the computer and the radio to work on the same network. Now, to do that, what we then can do is we actually have this utility called the Discover utility, which I've popped up here on the screen. Now, what this Discover utility is designed to do, it's designed to send out a special type of Ethernet packet onto the network. Any Horizon radio, or any of our radios, to be honest with you, that are out within the network will show back in this list, and it'll go by the serial number, the wireless LAN MAC, the Ethernet MAC, the IP, net mask, all the parameters of that radio. So let's go ahead and use this. We just come down here and push this button called Discover. Now, as soon as we do this, it sends out a packet, and what I have connected to my switch here is I have one ESTeem Horizon 5.8 gigahertz radio. It's currently configured in the AP bridge mode. The SSID is set to ESTeem, and the IP address is set at the factory default, which is 172.16.8.1, and then the last two digits of the serial number. That is the factory default address. All of the radios leave the factory at what's called a Class B address, or this 172.16 net masking. If you need to change the IP address of this radio, there's two ways to do it. You can actually just simply double click within the IP address field and change the number to whatever value you need it to be. The next option you have here is if you do a right mouse click, you can go down to where it says change the IP address, and what it will actually do is put a little pop-up window that then asks you what IP address you want it to go to. Either way, as soon as we press OK, what it will actually do is it will go and configure that radio for that IP address that we have used. And then as soon as it's programmed that address, it will actually reboot the radio and come back up. So as soon as I have my Discovery back up here again, let me put it back over here on this screen so it's a little bit easier to see. I'm going to hit Discover. We see here that this IP address on this radio is 172.16.8.169, and I have my computer that we plugged into set to exactly the same. So either I can open a web browser and manually type in this address, or we've kind of shortened that a little bit to where if you do click on the IP address, do a right mouse click, you use this first button down here that says Configure Radio. What it will do is it will open up the default web page and ask to enter in the information. I'm going to switch over the screens now so that you can see exactly what I'm making reference to. Now we should be looking at the web interface of the radio, and the first thing that's going to ask us to do is sign into the radio. There is the ability to actually change what this default password is, but by default it will use the username and password will be the same, all lowercase, admin, A-D-M-I-N. I'm going to type that in for the password, A-D-M-I-N also, and then hit sign in. And as soon as we do, we'll see here we're actually into what we call the home page of the radio. Now, if you immediately wanted to change your admin password, that's where this first button can actually allow us to do this. The next thing is that as you see here, we've got a tremendous amount of information available on the screen. You go ahead and, here we go. I'll grab the highlighter for this particular one, and hopefully that will show up here on your screen. So what we want to see is this first section is this allows us, this gives us the information of the basics of the radio. The serial number for the radio, it currently has no name, it's in a horizon, the bootloader information, and the mode of operation. The next portion refers to the wireless portions of it. What channel it's set to operate, what the wireless MAC address, whether or not the peer links have been enabled, and as we mentioned to you before, there are actually two Ethernet interfaces into the radio. And the Ethernet interfaces into the radio are listed out, Ethernet device 1 and device 2. Those are the two different ports on the front of it. Depending upon the mode, whether the radio is in a bridge or routing information, this is what the bridge IP address, and you can see here, the IP address for the bridge is going to be the same as that on the primary and secondary Ethernet port in the bridge mode. So that's kind of a quick tour to what we have available. The first thing we need to see is beyond the home page, we can actually go, the next page we'll click on is the setup tab. Now the setup tab is where most of our work is going to be done. This is where we're going to set the mode of operation. This is where we're going to enter the information for all the parameters on how to do it. The next tab over is the wireless status. This is going to give us a tremendous amount of information as far as what the radio can see. When we get in to start troubleshooting the radio, this is going to be what we're going to look at to see what is the signal strength of the remotes that we've configured, what other access points are available within those given channels, and all the primary information. So we will cover the wireless status in much more detail. On the 7th class within this series, we're going to take a look at this advanced page. We're going to not only cover this web interface in much more detail, but we're going to go in and take a look at what are the parameters that are set within this advanced and how are they used within an application. The backup, this is the ability within the radio to actually create a local backup or to actually write or read information off of the internal memory card. The memory card is a very powerful tool in that it can actually save the information from one radio. You can physically remove it, place it into another radio, and tell it to use those shared settings. And what that'll do is that'll create a clone of that radio within this larger network. We'll see why that's important once we actually get to the troubleshooting side of this. The restore is how we take those saved files, either the file that is shown here, that we have here, or we can actually do it from the internal memory card. The other two that we have listed there, which is the factory defaults or the last committed changes, these are the settings to where if we needed to blank the radio out and start from as if it just left the factory, we click the factory default. If we are within the web browser and we've made some changes to it, we get called away, come back to it, and then not quite sure where to go to, you can easily just press the last committed changes button, and it will be as if all of the configuration changes that you've made during the session have been removed, and it's as if you've logged into the radio once again. It's a nice way to get back to it going from an unknown state to a known state. It's not that you're going to use it each and every time, but if you do come across that situation, it is nice to be able to know where that's at. The next thing we're going to take a look at is the log file. Well, the log file is a running block of information on what this radio is doing. Between this and the system details button, these are what we may ask for troubleshooting it, and these are the things that we would then need to see of what's actually happening within this radio. This is essentially, it's a full-blown computer. So we would need to process what information is coming in and out of that to be able to help troubleshooting if we get into that kind of situation. The next tab, which is the CPU status, this again gives you more detailed information as far as what's going on within the radio. The current date and time, which doesn't look like I actually have set within this radio, the current internal temperature, and also information as far as the running uptime within the radio. Now, what this will do is this will actually start counting off days. It also tells us what are the current states as far as the CPU idle, the pageable memory, everything that has to do within the CPU of that radio is going to be listed here. The update tab, This one allows us to update the firmware to the radio, either through an image file that you can generally download off our FTP site, or it may be sent to you through the support channels, or we can do it through an HTTPS certificate. Most of them will actually be done through the imaging file. Reboot is the same as pressing the reset button on the front of the radio or unplugging it and plugging it back in. This just allows you to reboot the radio if it is mounted onto a pole out into open air, or you need to reboot a remote site. It just gives you the software ability to reset it. Again, this does not affect anything that has to do with the addressing, the modes of operation, or anything about that. The final tab up here is the About tab. And the About tab gives you information on where the radio came from and our phone number to it if you ever need it. The work that we're going to be doing today is actually listed here under Setup. Under the Setup tab, as you notice here, if we hit the little down arrow, you'll see here that those are all of our different modes of operation. AP Masquerade, AP Bridge, AP Router, Station Bridge, Ether Station, Station Masquerade, Station Router, and Ethernet only. Depending upon what mode of operation you select, the menu that you will go through as far as the configuration will be different. So what we see here on this section is going to only be true for the AP Bridge. If you select the AP Router, the menuing will change. If we select one of the station modes, the menuing will be changed. So don't panic if you see something a little bit different. The web interface will only ask you the questions that are necessary for the mode of operation you're programming it for. So, as we mentioned, the AP Bridge is the most commonly used type. So, what do we use? Well, let's go ahead and select AP Bridge, and we'll hit the button that says Next. It's going to ask us what do we want to do as far as the Ethernet interface. Are we going to be running a DHCP services? DHCP is what automatically gives your gives your computer its IP address. So in a lot of cases, if you're running DHCP, the radio, if it has a fixed IP, the DHCP is going to be turned off. The radio can also be configured to be a DHCP client or a DHCP server. Because in a lot of cases, if it's going to be an access point for many different Wi-Fi devices, you may want the radio itself to be handing out the IP addresses. So the radio can be configured for any one of those. For our purposes, we're going to give it a fixed IP, so the DHCP is going to be set to off. The next question it's going to ask us is, do we want this radio to be the root bridge in the wireless network? For our purposes, we're going to go ahead and leave that at off. Now, once we get to the actual programming of the radio through for mesh interfaces, then we're going to turn the root bridge to on or off depending upon where it's at within the network, which we'll explain in much more detail in here in just a couple slides. So for our purposes, we're going to leave it off and continue on. The next thing it will ask us is to configure the IP address of the radio. So if the IP address that you have listed here, which we have in our web browser, if we needed to change that, then we could actually do it at this page. We do it here, we set the net mask, and finally enter in the route IP address. Well, for our purposes, we're going to be using this in a bridge mode, so the default IP is not significant outside of the fact it needs to have some address in there. If you don't know if the radios will be running in AP bridge mode, and you're not familiar with what route or default route should be, you can just leave this at default. It will be perfectly fine. The only time that we'll need to make changes to that is when we get into the router or the firewall, which is the masquerade mode. Once we've established this, the next page that's going to open up is going to be a little bit different depending upon the mode, depending upon the radio itself. The first one is the channel bandwidth availability will depend greatly upon which radio we're talking into. Say, for example, the Horizon 900 radio only has the capability of doing 5, 10, and 20 megahertz. The 2.4 and the 5.8 can go anywhere between 5 megahertz and 40 megahertz as far as bandwidth. And say, for example, the 4.9 only has a 20 megahertz wide channel, so we don't have these capabilities. What this does is this tells us actually how wide of a channel this radio is going to operate. And as you see here, the channel data rate, or the available RF bandwidth, also sets to how much the actual speed can be. So a 5 megahertz channel only goes between 1.5 to 36 megabits. A 20 megahertz channel will go anywhere between 6 to 144. To get up to the 300 megabits of throughput on the 5.8 gigahertz requires a 40 megahertz wide channel. You can also see here on this next one, we talk about what Wi-Fi capability. Only 20 megahertz and 40 megahertz are available for Wi-Fi. So if you happen to be operating either the Horizon 2.4 or the Horizon 5.8, and you want them to be absolutely unseen entirely by Wi-Fi, if you use these two lower channels, 10 megahertz and 5 megahertz, any wireless client will never see those. So that is another method of security you can use. The next thing that we need to set within this is we've established what bandwidth. 20 megahertz for the 5.8 will be default, and in most cases that works relatively well. And we even put it that way. It's recommended for most applications. Excuse me. So if we look at the max disk setting, what we're talking about here is if you look at this radio and all the other fixed radios that it's going to be communicating to, what is going to be the direct furthest away from this site? If you're going through a repeater, you don't need to put in the distance from this site all the way through the repeater to the remote. It would only be from this site to the repeater. So you look at all the direct links that this radio communicates to, and the furthest one sets the distance. Now, this distance setting will not keep the radio from functioning, but what it will do is we're actually adding a small amount of time delay after each packet for very long distance applications. So if you set it for a maximum distance beyond what your radio is currently operating, then it's going to transmit the information. It's going to wait a certain amount of time, and then it'll transmit the next one. So it just loses efficiency. You want this max distance as close as you can get to the maximum distance within the system. That looks good. We're going to go ahead and press the next. The next question it's going to ask us is what is the operating channel or the operating frequency that we want these radios to go on. Again, this drop-down list is going to greatly depend upon which radio we're looking at. This 5.8 gigahertz actually has 13 different channels, and it's kind of unique in the fact that this one actually has both Wi-Fi and non-Wi-Fi channels within it. For example, channel 149 is a Wi-Fi channel. Channel 153 is also a Wi-Fi channel. 157, 161, and 165. These are the only channels that if you configure this radio for, that we can work with Wi-Fi clients. What that means then is 150, 151, and 152, those themselves are proprietary channels. So the 5.8 gigahertz is a little bit unique that the channel that you select will also dictate which kind of device it will communicate to. For much more details on how the channel breakdown is, we really suggest you look into the user's manual for each one of the individual radios themselves. So for our purposes here, we're going to leave it at default at channel 157, and we'll go ahead and select next. Now, the channel that you're operating on, this could be assigned to you by either what was found during the radio site survey, or what IT has provided to you, what your frequency allocation has provided to you. Any one of these could dictate what it is. If you're not really certain on where to start with, especially on these unlicensed frequencies, a good place to start with is start in the middle. Check to see if it's operating the way you want it to, and if it isn't, then move off to a different channel. That is the beauty of these unlicensed frequencies, is that you can move around within them, and there really is no ramifications to it. Okay. This first question now is, we keep in mind what we're programming within this radio is we're programming this radio for AP bridge mode. So we actually have to configure two different sides. The access point side, where we set the radios up to to bring in mobile clients. And then the last side is where we configure the bridge. So the first few questions that it's going to ask us are based upon configuring the access point side. So an easy way to tell this is anything that deals with an SSID or service set identification, that is the network name when dealing with mobile clients. All mobile clients that use with this access point radio or this radio and access point mode need to match this SSID, and it can be alphanumeric, it is case sensitive, and it can contain spaces, but the two have to be absolutely identical. The next thing is that depending upon the rates that you want the radio to operate, or what type of connected devices it's going to have, we either use the high throughput rates, which are recommended, requires a specific or a minimum of WPA2, which is one of the encryption types. If you're going to be using older hardware or to get this radio as a Horizon 5.8 to be compatible with the 195E series, then we would have to set this as standard rates. And depending upon which one we select here is going to then populate the next screen. I'll show you what I mean by that. If we put it as high throughput rates and select next, what this will do is this will only show the data rate, or excuse me, the encryption types from WPA2 all the way to WPA2 256. Let me go ahead and press the previous button. If I select standard rates and select next, we'll see here that we have a tremendous amount of other options available to us. Let's say the WPA, the WAEP in both 128 and 64-bit, or turning off encryption entirely, that can only be done in non-high throughput rates. It's just the way that the definition for how the connected clients would be. Let me show you what I mean by that. I'm going to press previous again. So for all the radios to connect into what are called 802.11n rates, or to use the high throughput rates, we have to force it to be WPA2 encryption or better. It's just the way that the specification is laid out. So because of that, we usually recommend that because most modern equipment will work within that, so we select next. As you notice on here, we actually have two different types. We have what's called PSK, which stands for pre-shared key, and we also have what's called an enterprise mode. Now, an enterprise mode actually uses a radius server back at the master or back at the base radio. That radius server can use both username and password. It can be a specific certificate loaded to your laptop. Really what it comes down to, that's a function of how the network management is done. We don't define how that is done. That's actually an end user specification. We just put this in here so that we support it, whether we're using WPA with pre-shared key, which means that we enter the information. You may put in a password that's your name, and then everybody that wants to join the network also has to put your name into it. That was what would be considered a pre-shared key. Enterprise means it goes off and talks to a secondary server in the background. It gets its information from the server, passes it through the radio, and if those aren't correct, the radio will not allow it to link. There's just different methods of using it, primarily seen on more complex Wi-Fi networks. We can either support, the defining feature right here is the length of the encryption key. It's either AES 128 or 256-bit. These are how high level of security. 128 is a tremendously secure networking type, but a lot of things are pushing towards 256. That's one of the main reasons we have it in there. The next generation of Wi-Fi that's going to come out is it's going to have something here called protected management frames. Really what those are is that by default, the header information that's sent out, it's sent out in unsecured format. They are going to eventually secure those, which would be a protected management frame. For most cases, it really comes into the Wi-Fi clients that are entering it and what capabilities they have. So you'd set up your access point for how you want those Wi-Fi clients or the connected clients to actually access the network. The next one is the beacon SSID. Everybody's kind of familiar with this, whether you realize it or not. When you turn on your home Wi-Fi, or you go to a building or go to a shopping center and you open it up your phone or your tablet, you see on there a list of available access points out there or connections into a wireless network. That is what's called the beacon SSID. In other words, it's sending out the SSID into the open air. If you don't want that, what you can do is you can push I want to hide the SSID. So in the case of this, it does no longer broadcast it out. So you not only need to know the network name within the system, but you'd also have to know the SSID to be able to enter the network. These are all just multiple layers of security. As you can see, what they are is they are progressive on how complicated you want them to be within the network. As you'll see as we get towards the end of this, we can set up the radio for a tremendous amount of different types. It really comes down to what are the network requirements for the system that we're putting it into. The radio itself is capable of just about anything. Okay? So because we have no particular concerns with what is our encryption type for this, the access point side, we're just going to leave everything at default and press the next button. The next thing it's going to ask us is really dependent upon what we selected in the previous page. So since we selected pre-shared key, it's going to ask us for a passphrase. Now that passphrase can be anything. It can be anywhere between 8 to 64 characters. It can be a name, but it has to be entered exactly the same way, both on the access point and the client side. Again, it's alphanumeric and is going to be case sensitive. So it's just another way of locking it down. But from here, I'm going to press the previous button and show you the difference. If we select enterprise, and it's going to be the same whether we use 256 or 128, it's exactly the same. But if we select enterprise and select next, it's now going to ask us, where do I find this radius server, both in the primary and secondary, by IP, port number, and the entering of the passphrase to it. Just like we saw when we were looking at the availability as far as the modes of operation, depending upon what we select through this menuing system, it could be a little bit different, but it's never going to steer you wrong. It's never going to put it in front of you the question that has nothing to do with the mode of operation you're dealing with. Okay? So what we're going to do is we're going to leave it at pre-shared key. We're going to leave the passphrase at default. And we're going to continue on, because the next page it's going to ask us has to deal with what's called an access control list. Well, the access control list is just another way of making the network function exactly as you want it to do. What this is this is just a simple MAC filter. This actually then allows us to put within there specific MAC addresses for clients. So if you had a laptop, what you could do is you could enter in, allow only the MAC address of that laptop to enter into this network. So again, what you'd have to do is you'd have to know the SSID, you'd have to get the security correct, and then you would also have to pass this MAC filtering. So these are just additive ways of making the network more and more and more secure. If it's not a concern of locking down particular clients, what you can do is leave the access control list at allow all. The one little side note that I want to bring into this is this feature, this access control list, is kind of a unique idea, because what it does is this will also allow us to turn access point mode on or off. And what I mean by that, if we put in here allow only those MAC address stations in the list below, and we leave the list blank, what we've effectively done is we've turned off the access point linking for this radio. This is a very special mode for it. It isn't necessary, but it is, again, just another layer of security that you can use. So for our purposes, we're going to leave it at allow all, again, trying to leave everything as default as we can, and then we select next. Now, this particular mode, which is what we call the peer setting, This is where we configure the radio to operate with other fixed point radios within the network. Now, what I mean by this is you use this mode to configure this radio to link to other fixed radios or other non-moving radios within the network. You do not need to enter any radio that is in a station mode into this to create a link. That link will be created from the access point, what we just configured previously, the SSID, the encryption, and the access control list. This is specifically for the fixed locations and the mesh clients only. So to create a link to another radio, it's very simple. All we really need to do, if this radio is going to be communicating directly with another ESTeem in access point router, access point bridge, or access point masquerade, any one of those modes, then we always need to do is press the add button. And what that'll do is that'll pop us to another page. Now, this second page, what this is designed to do is this will then tell us what parameter do we need to set within this radio to get it to talk to another one. Well, as I mentioned to you in the very first section, we're just replacing the two lowest layers in that Ethernet stack. So you could just enter the MAC address of the other radio because the radios actually communicate at the MAC layer. We don't care what protocol goes over the top of ours. We also have made this a little bit simpler. So the only thing that you need to either enter is either the serial number or the wireless LAN MAC address of the radio. So I've grabbed another Horizon 5.8 that I'm going to configure here in our network. And its serial number is Z-26070. So I could type that out, Z-26070. Or I could even shorten that up to just the numbers is really all that I need. The next thing it's going to ask us is path length. Well, when we get to the next section, which we're going to go through how to configure the bridge and how to make the mesh function the way we want it to, that's where we're going to make adjustments into the path length. The next question is going to be which type of radio is going to be that specific remote connection. We can either link to a Horizon radio, which means it's going to automatically push it towards the high throughput, and we need CCMP encryption, or we can set it to the older series, the 195E series, that allow us to link into an existing network so that you could do an upgrade on that network without having to replace all the devices in the system. One of the things that we had talked about in an earlier class was how we work very hard at making sure these networks or these radios are downward compatible. We try to keep at least the previous generation, if at all possible, so that you're not re-putting out new hardware for each one of these systems that you put in. So for our connection, again, I'm going to be putting it to a Horizon 5.8, so I've entered in the serial number. The path length, I'm going to leave it default at 1. We're going to be talking to a Horizon, and then it's going to ask us, we need to use at least CCMP, so we've got two of them. We've got 128-bit and 256. You could leave it at 128-bit because it already has an encryption key listed down here below, the default encryption key. You could also set it to 256, which means that essentially we need a longer encryption key, and it will change the default key for that also. As you see here, it expanded the length of this. I'm going to change it back to 128, and you'll see it shortens it up. Another method is, if you don't want to use the encryption key, you can manually just type in. This actually uses 16 hexadecimal digits. You could make up your own, make up entirely your own key. If you don't wish to do that, what you can do is you can just simply use a link ID and a passphrase. So we can call this training. And the passphrase we're going to call this is test. And what it will do is it'll use these two variables, and you can press generate key. And what it will actually do is it will use these two parameters and come up with an encryption key that is unique for it. So if you just type in the link ID and the passphrase exactly as it was listed before, what it will do is it'll create this exact same encryption key at the opposite side. It's just another method of making it easier to enter in or to create these links. I found that in most cases the default key is more than sufficient for this, because keep in mind, as we talked about earlier, this is a proprietary link. This is not something that anybody's going to be able to pick up off the air and to decode it. We can also in here select advanced settings, which we'll cover in much more detail when we get to the advanced section of our class. But this also just is some parameters that happen within this link that we may need to adjust in the future. So for our purposes now, we're just going to leave it to where we hide those advanced settings. So all I'm concerned with really is putting in the serial number of who I'm talking to and making sure I know what the encryption key is. If that's done, I simply hit create peer. And what this will do is this will generate and add a peer to 26070. This is the wireless MAC of that radio, tap length of 1, encryption type, high throughput rates. And what we've done is we've used what's called dynamic rates for both the standard rates and the HT rates. A dynamic rate means the radio will go as fast as it possibly can given the conditions that it has based upon the serial number. So we usually recommend that in most cases unless you need to alter those bands. So if it's in a condition to where we know it's never going to get above, say, 26 megabits, then you might only put so that the maximum data rate on that link is 26 megabits. There are just ways of fine-tuning it. But for our purposes now, this is a very standard configuration for what we want the radios to look like. We just enter the serial number and leave the path length at 1. I'm going to hit the next button. This is then going to take us to the last and final page. What I'm going to do is I'm going to call this site the master. Okay? When we look at future troubleshooting sections, I'm going to actually add another radio in much the same way. And so you'll see it listed by this radio ID. This radio ID can be anything. It can be alphanumeric, a street address, a room name. It doesn't matter. This just helps identify the radio within the overall network, both in the wireless status page and also it will show up in the discovery by this name and also off of our home page. There are also 2 other security mechanisms which we can do here. The first one is do we want the Discovery Suite configuration tools? Within the Discovery Suite, you have the ability to save configurations and update those configurations and set things back to factory default. And there's a lot of programming tools that you can use within the Discovery, but you also may want to turn those abilities off so that you can just read the information out of the radio, but you don't want to be able to access or change those within there. That is what these enable and disable do. If it's enabled, the Discovery Suite tools will work. If it's disabled, you're effectively turning those off. The next thing when we're talking about a remote assistance. By default, you can always contact ESTeem. We can get online and help you out with the radios. If you want to lock it down so that that feature is turned off, if you turn remote assistance to disable, then the remote assistance will be turned off within the radio. Please keep in mind, once that's done, that we no longer have access to that radio as far as any passwords or usernames. So if they're changed and it's forgotten what those are, there's nothing that we can do to help. The only possibility at that point, if you disable the remote assistance, is the radio would have to be shipped back to the factory and we'd have to essentially hard factory reset. So in most cases, you can leave these at enable. Those again are just added levels of security. Most cases, that's fine. So as you notice here on the bottom, we can either go to the previous button, we can commit the changes, or we can jump to the advanced. Well, everything that we've done as far as configuration changes within this radio, what we're doing is we're creating a list within this that then will push that information towards the radio. It's always a 2-step process: programming, saving those programs, or programming, committing those changes. So although we've made parameter changes to the radio, they really haven't taken effect until we come over here and press this button called Commit Changes. I'm going to go ahead and do that now. As soon as I hit the Commit Changes button, what it will do is it's going to come back and tell you that this radio is actually rebooting. And it will be operational with your new configuration settings as it comes back up. The horizon takes about 45 seconds for it to reboot. So What we'll then do is we're going to go ahead and let that reboot. We'll come back here once it comes back up and we'll hit go to home, and we'll see some of the changes that we entered there. Primarily, the biggest thing we're going to see a change at is the ID number for the radio. Now, this will look familiar if you've gone through the previous sections of our utility, because this is our redundant path layout and why we needed to do that. This is how we're actually going to configure these radios. What I'm making reference to that is when we're talking about this industrial mesh, there are two ways that a mesh type of technology can be entered. The first one is where you manually enter the priority of those. You take direct control of the routing. The next one is if you let the radio do an auto configuration. The difficult part about the auto configuration is the radio has to make some intelligent choices, and you have to fix those, decisions when the radio is designed. Is it going to go to the shortest path? Is it going to find the highest signal strength? What do you want it to do? In most cases, those two rules never apply to everything. So what we've done is for our industrial mesh technology, we've got it to where the system is actually configured manually, and then you set within that the priority. These multiple links, as we saw on the previous page, is what creates that spider web or that mesh networking. The functioning of it, though, if a link ever were to be lost, it will automatically reroute the information to a different location. Therefore, we call that self-healing. Now, what actually happens there, what's happening in the background, is nothing new. We're not making this up. We're actually utilizing a function of normal Ethernet, hardwired Ethernet, called spanning tree protocol. Now, what this does is this is automatically designed, even in a hardwired network, to look for all of the redundant or all of the multiple routes within the system and define within there which ones are we going to use. Because if a radio has 3 different possible ways of getting communication to one single destination, if it sends it out, essentially it's going to get 3 copies of it at that one site. Which one does it deal with? And also, which one does it respond to? You don't want it to have to deal with this inevitably. So how do we limit that? Well, hardwired Ethernet's already done that. And so what we've done is we've modeled that spanning tree protocol on the wireless side. So our peer links, as we said before, you either do it by the serial number or the MAC address. You select the radio type, the path length, the encryption type, and the data rate, just as we saw on the previous page. Now, what we're going to concentrate on next is what did this path length do? The next thing is another feature of the spanning tree protocol is that term that we saw earlier, which is root bridge. Okay? The root bridge within the network is the point to where all the other locations make a reference to, not necessarily talking to directly, but so for example, in a wired network, whether it's actually happening, whether you realize it or not, but the devices that are connected are actually electing a root bridge. Because in a wired network, to be honest with you, who the root bridge is doesn't really matter. In a wireless network, it becomes incredibly important because we want to tell the system this is going to be the base reference point. All paths within a spanning tree protocol point back to what is the shortest way to get back to what's listed as this root bridge. You may also hear this term rapid spanning tree protocol or multiple spanning tree protocol. Those are just different. The process is exactly the same. The only difference is rapid spanning tree protocol, it actually keeps a list of all the available routes to it. If the primary fails, it automatically switches to the second or the tertiary. In a normal spanning tree, if it loses the link, it actually goes out and does a calculation. It's just different evolutions of the spanning tree protocol. The radio actually does all 3. Again, one thing to keep in mind, what we're talking about here is fixed locations. In other words, those that are also configured as access point bridge, access point router, access point masquerade. Mobile clients do not need to be configured in this list. So how does this work? What are we talking about here? Well, let's go ahead and think of this on a very simple network. 3 radios is kind of the easiest way to conception. You can see how it would expand out from that. What we have here is we have a plant network on the upper side here. What we're trying to do is we're trying to link this out to a remote building out here at the remote. Well, we did some RF testing. We found that we can create a link going between the access point at one side and the access point bridge at the opposite. So you see here, we even have this one in router mode. It doesn't matter which mode of operation we use. This peer meshing is going to be exactly the same. So because of that, we actually have 2 routes. We have one route here as the backup, and we also, the reason that we're going to consider this the backup is this one here only gives us a minimum speed going directly between the radios. Because of this distance, let's say the maximum speed we can get this to run is 11 megabits per second. But we can actually get on both the primary link to the repeater and out of the repeater, we can get that going at 96 megabits per second. So overall, what you get, even though we're cutting it by 2 by going through the repeater, the net result will be faster. So what we really want to do is we want this link, get rid of this one here, we want this link going between the base and our remote who we're talking to. We want the link going through the repeater site to be the primary path and the backup path. Well, let's go ahead and take a look at what happens then. How do we get this to work? The first thing is that we then would determine who the root bridge is going to be. Well, in our network, that's going to be real simple. We're going to make this side up here the root bridge, because that's going to be our base radio. We're going to bring other radios into this network. So what happens then is that when you configure this, so this master radio will have 2 peers, one to this radio and one to this radio. And by default, all of those path links, okay, let me put this up here. This one is also equal to 1 by default. So the way that this works then is that if we look at this radio, the standalone repeater, because all of them will go through the same process, this one actually has 2 ways of getting back to the root bridge. We can either send it this way, or we can send it this way, because it'll actually go through, come through this one, and bounce this direction. So from the repeater standpoint, we have a path length of 1 going back to our root bridge radio, but going through the secondary path, we have a path length of 1 plus 1. So the path length going this way will actually be 2. So what it does, it says, okay, what I'm going to do is I'm going to then use this pathway right here as my primary, and I'm going to forward the information on this one, and I'm going to save this one in my list here and only use it if I lose this communication path going forward. I'm going to block this path to begin with. If for whatever reason this link comes up and gets lost, then it will automatically switch over from forwarding on this one to forwarding on this one, and the communication still goes through. That's the overall essence of the communication type. So, oops, I erased my path link here. Bear with me. I'm going to write this back. Now, so for our repeater site, we really need to make no adjustments to the path link, because we want this to be the primary pathway, and we want the link going the opposite way to be the backup. All works great. The concern really comes down when we start programming this one. Because if you notice down here, what this does is this is also going to have 2 peers, one going to the repeater and one going directly to the master site, which we want to be the backup repeater. So what's going to happen then? Well, if we do this, what actually happens is that the direct pathway from this remote to the master will have a path length of 1. The pathway going through the repeater will have a path length of 2. If we make no adjustments to the configuration on the radio, what actually happens is this would be our primary link, this would be our secondary link, and that's the way the radio would function. Now, the problem is that that is not how we want it to work. we want to force it to go through the radio. How do we do that? To be honest with you, it's as simple as simply making the radio think that it is using the same rules that we made before, but we're going to fix the game. To do this, all we need to do is to create this backup repeater path, is to make it think that the path length between the route going direct is longer than it takes to go between the other ones. So our path length of going through the primary repeater would be 2, and our path length of going through the backup will be 3. So what happens then is the radio says, oh, this is a shorter route to the root bridge. So what I'm going to do is I'm going to use this. I'm going to forward on this one, and I'm going to block my backup path up until the point to where we would lose this radio. Then we already have a path established here. Therefore, we can control exactly how we want the radio to work. Now, this works fantastic in a lot of cases. Just keep in mind the only time that you're going to need to make any adjustments to this path length if we're running it in what we'll call an unnatural state. For example, if we wanted this to be the primary and we wanted a backup to go through here, then we could leave all of these at a path length of 1 and it would function exactly the way we want it to. The reason that we don't go crazy and just start putting a random bunch of numbers out here is, let's say, for example, we had a couple other remote sites out here that use this as a repeater also. So if we set this pathway up to, say, 3 on one of these, all the sites that are going to see that link are also going to add that path length in. So it becomes very dynamic on the way things are. So the only adjustments that you really want to make to those are that are necessary. So for our cases then, as you see here, it just becomes as simple as making the radio think it's going a different route. So that is the extent of really what it takes to get the radio to function within this mesh configuration. Where we're going to take a look at in part 2 of this is we're going to take a look at the different modes. Everything that we talked about now was the access point bridge. We still have actually 7 different modes of operation to go through. But as you'll see here, once we get past the bridge, they're all going to look very, very similar to this. So I think this will probably be a good stopping point. So I want to thank everybody's time, and you have a great day.